In this video, we are going to be doing this question, which I have adapted from the EC June 2023 examination. This is obviously a question about functions. So as we can see, here we are given a diagram which shows us the graphs of f, and f is a hyperbola. And we are also given a graph of g, which is a parabola or a quadratic function. So we are told that these two graphs intersect at S, which is the y-intercept of both graphs. And we are also told that R, as shown in the diagram, is the x-intercept of f, that is the hyperbola. And the asymptotes of f cut at T, which is the turning point of G, our parabola. And the first question is write down the coordinates of S. So the instruction is write down, so you do not need to do any calculations. As it was stated in the statement, this is the y-intercept for both graphs. However, for the graph of f, we do not have the complete equation, so we cannot be able to use it to find the y-intercept. However, we've got the complete equation for g. And we know that for a parabola, the y-intercept is given by the constant c. So the coordinates of S are going to be 0 and 3. Simple like that. So the next question, 4.2 and 4.2.1, is asking us to determine the coordinates of T. So remember that we were told that T is the turning point of G, the parabola. So this is very easy because we know that at the turning point, the x value, which is also referred to as an axis of symmetry, is given by negative b over 2a. So using this formula, we can be able to find the x value of the turning point. So b in this quadratic function is equal to 10. So we'll have negative 10, and a is equal to 5. So we'll divide that by 2 multiplied by 5. And therefore 2 multiplied by 5 is 10, and therefore negative 10 over 10 will give us negative 1. So this is the x value of the turning point T. So now we just need to work out the y value. We can just substitute in this x value to our original equation of g. So we need to work out g of negative 1. So we just substitute in negative 1 throughout the equation. So we'll have 5 into negative 1 squared plus 10 into negative 1 plus 3. So this is going to give us 5, and this will give us negative 10 and then plus 3. And so we can just sum up all of these. 5 minus 10 is negative 5, plus 3, that will be negative 2. Therefore, with all of this, we can now conclude that the coordinates of T are negative 1 and negative 2. And now that we've got these coordinates, let's just make things easy for us by noting them on the diagram. So we had already found that for S we have 0 and 3. Now we know that T here has got coordinates of negative 1 and negative 2. So now let's move on to the next question. Now in 4.2.2, we need to determine the values of P and Q. So P and Q are values within the equation of the function of f. And so for this one, you need to understand the properties of a hyperbolic function. And it's very easy. The value of P here gives us the vertical asymptote, or in other words, the x asymptote, while the value of Q gives us the value of the horizontal asymptote, or in other words, the y asymptote. But now, for the x asymptote, bear in mind that if you are trying to work out the x asymptote, you should take this denominator x plus p, and then you equate it to 0. And so after doing that, you transpose p to the other side. And so this x is equal to minus p, or in other words, minus p will give you the value of the vertical asymptote. And so now, if we go into our graph here, specifically looking into the hyperbolic graph, we can see that here are the asymptotes. So the vertical dotted line is the x asymptote. So this is our x is equal to negative p. And then on the other end, this is our horizontal asymptote. So this is our y is equal to q. Okay, and we're told that these asymptotes of f cut exactly at this point t. So the value of the vertical or x asymptote will be exactly equal to the x coordinate of t. And likewise, the value of the horizontal asymptote or the y asymptote will be equal to the y value of this coordinate t. So if we start with p, so bear in mind that we're answering 4.2.2. So we can say that x is equal to negative 1 because the x value of t is negative 1. And therefore, this means that negative p is equal to negative 1, which then means that p is equal to 1. So this is one of the ways on which you can work this out. And now for q, q is straightforward. The value of q will just be simply equal to the y coordinate of t. So it will be equal to negative 2. Now, for 4.2.3, we need to determine the length of OR. So we are looking here. It's from the center to that point. So we know that the coordinates there are 0 and 0. So the next thing is we need to know the coordinates of R in order for us to be able to work this out. And we can say that, in fact, we're told that R is the x-intercept of f. So we can just simply work out the x-intercept of f, because right now we do know the complete equation for f. It will be 5 over x plus 1, because the value of p is 1, minus 2, which is the value of q. And then from here on, we need to find the x-intercept. And so we know that to work out the x-intercept, we need to let y equal to 0. So in this case, this basically means that we need to let f of x equal to 0. So we'll have 0 is equal to 5 over x plus 1 minus 2. So let's transpose negative 2 into the left-hand side. And now here we'll be left with 5 over x plus 1. And now we can just multiply by x plus 1 on both sides of the equation to get 2 into x plus 1 equal to 5. And now the next thing is we need to expand by 2 here. So we'll get 2x plus 2 is equal to 5. And now we can transpose 2 into the other side. So we'll have 5 minus 2 on the right hand side. And on this side we'll be left with 2x. So 2x will be equal to 5 minus 2, which is equal to 3. And therefore x is equal to 3 over 2. And therefore the coordinates of R are 3 over 2 and 0. Okay, and from this, so I might as well just write these coordinates here. We might need them in the next questions. So now to find the distance or the length of OR, so here you don't have to use the distance formula because this is perfectly a horizontal line. So the distance from the origin to R is simply going to be given by the x value of R. So the length OR is going to be equal to 3 over 2 because this is from the origin from 0 up to 3 over 2 units. So that's it. Now, the last question here under 4.2, that is 4.2.4, is asking us to determine the range of G. And so that is our parabola. Now remember that by the range, we are referring to the possible y values of that function. So here, if we look into the y values of g, we see that if we start from the bottom, the first y value that we get for g is at the turning point. So what's the y value there at the turning point? We know that it's -2. And then this can now go upwards and go on and increase up to infinity. So this means that the range of G is going to be y is greater than -2 or equal to -2. So the range would be y is greater or equal to -2 because our first y value that we can get from G is -2, and every value that is going to be greater than -2. So alternatively, you can also express this as the range is equal to y is an element from -2 up to infinity. So you can also express it in terms of the set notation. Now let's go to 4.3. 4.3.1 is asking us to determine the equation of the tangent to G at S. So imagine that our parabola had a tangent line. So if I were to sketch such a line, it would be something like this. And remember that by definition, a tangent line is just a line which only touches a curve at one point. So this line here would only touch the graph of G at that point S. So for this question, we need to use our knowledge of differential calculus. And from differential calculus, what we know is that if we take an equation of any graph and then we differentiate it, we are going to get a gradient of that function at any value of x. So this is what I mean by this. In this case, since we are trying to find the tangent to G, we are going to take the equation of G. So we'll take G of x here, and then we are going to differentiate it. So for 4.3.1, we need to work out the derivative of G. And so this is going to be given by 2 multiplied by 5, which is 10, multiplied by x into 2 minus 1. So it will just be 10x. And then for the second term, the exponent there is 1. So we have 1 multiplied by 10, which is 10. And then we would have x into 1 minus 1. So that's equal to x to the power of 0, which is equal to 1. So therefore, that term will just be equal to x. And then now the derivative of a constant is just 0. So this is the derivative of g of x. And now this here can give us the gradient of g at any point, but now we specifically want to determine the gradient of g exactly at this point S. So to do that, we need to substitute in the x value at that point S. So the x value is 0 then, as we can see from the coordinates of S. So therefore, g prime of 0 is going to give us 10. So in other words, this is the gradient at S, which means that a tangent line at S is going to have a gradient of m equals to 10. So now we have determined the gradient of this tangent line at S. And we know that the equation of a line is given by y is equal to mx plus c. And we now know that m is equal to 10 here. So in order to determine this equation, what we are left with is the constant c. But guess what? We do not even need to calculate it here, because as you can see, if this tangent line is at S, it means that it is going to cut the y-axis or intersect the y-axis at S as well. So its y-intercept is going to be the same as the y-intercept of G and F. So it is going to be equal to 3. Therefore, the equation of this tangent line is going to be given by y is equal to 10x plus 3. And so the last question from 4.3 is asking us to determine the axis of symmetry of F with a positive gradient, right? So specifically, an axis of symmetry with a positive gradient. So if we have a hyperbola, we know that we have two axes of symmetry, and generally these axes of symmetry are going to have the equations y is equal to x plus c, and the second one will have an equation of y is equal to negative x plus c. So this one, as you can see, it has a positive gradient, while this one has a negative gradient. And in this question, we are being specifically asked to determine the one with a positive gradient. Now, visually, you must also know how they look like in the graph. So if I were to sketch them here, the one with the positive gradient would look like this. So as you will see, it's passing exactly at the point T whereby the asymptotes intersect. And so the other one is also going to pass there, but this one has a negative gradient. As you can see, it's a decreasing line. So this is how these axes of symmetry look like. And the one that we want to find is this one. And we know the coordinates of that point, so we are going to make use of them in determining this equation, because the only thing that is remaining for this equation to be complete is just C. So to answer 4.3.2, what we are going to do is we'll just substitute the coordinates of T in this case, which are -1 and -2. Exactly where the axis of symmetry pass through. And so if we substitute this into this general equation, we will have -2 is equal to -1 plus c. And then we just simply transpose -1 into the left-hand side. So we'll get -1 is equal to c. Therefore, the equation for this axis of symmetry is going to be y is equal to x minus 1. Now, the last question, 4.4, is asking us whether for which values of x will the derivative of g multiplied by f of x be less than or equal to 0. Okay, So for this question, here is the trick. For simplicity, I'll just erase some of these lines, in fact, including that tangent line, so that we don't have too much going on that diagram. So let's think about how would the graph of the derivative of g look like. Okay, so we can easily be able to sketch it here because we had already found that its equation, the equation of g prime of x, is equal to 10x plus 10. So this means that to sketch this graph, you can simply do so by finding the x-intercept and the y-intercept and then join those two lines. So for the x-intercept here, we can just make y equal to 0. So we'll have 0 is equal to 10x plus 10, and then we transpose 10 into the other side. So we are gonna get this equation. So if we divide by 10 on both sides here, we are going to get that -1 is equal to x. So the x-intercept here will be at x is equal to -1. And we can also say that the y-intercept is going to be 10. So since s here has a y value equal to 3, we can say that 10 would be there, maybe. So we can just join these 2 points to get an idea on how the graph for g prime of x would look like. So something like that. Although it's not in line with my point, so I'm gonna change it slightly to there. So this is what I'm taking as 10. So that point there is 10. So now, going back to the question, we need to determine values of x, whereby if we take g prime of x and we multiply it by f of x, we are going to get a negative value. Remember that g prime of x just simply refers to the y value of g prime, and this also refers to the y values of f. So we are now looking for the values of x, whereby if we multiply the y value of the derivative of g and the y value of f, we are going to get a negative value. Another important thing that we need to bear in mind is that if we are multiplying two numbers, we can only be able to obtain a negative value provided that the signs of the two numbers that we are multiplying are not the same. So in this case, it means that this would be true. So for 4.4, this means that we can be able to get a value that is less than 0 if g prime of x is less than 0 and f of x is greater than 0. Alternatively, we can also be able to get a product that is less than 0 here if g prime of x is greater than 0, while on the other end f of x is less than 0. Because as long as the signs are not going to be the same, then the product will be negative. But now we also have here or equal to, so obviously either one of them can be equal to 0 in order for us to get a product that is equal to 0. So now let's go back to our diagram here. So first thing, we can say that on this side, f of x is always less than 0. However, if we go upwards, exactly considering, this domain of f, we notice that even g prime, so remember that this is our g prime, so even g prime is also negative on this range. So it means that at any given point here, if we take the y value of f and the y value of g prime, they are both going to be negative, and therefore we are going to get a positive value here if we are multiplying them together. So the x values on this range are not going to work. Now, if we move on to the values starting from here, we say that the y values of g prime are all positive. So g prime is above the x-axis, right? However, even the values of f, because now this is the part of f we have to consider, even the values of f are positive up until we reach r. So from this point up to point R, all the values of our G prime and F are positive. Both of the graphs are positive. So if we multiply them together, we will still get a positive answer. However, interestingly, starting from R onwards, as you can see here, F is negative here. The values of f are negative, while the values of g prime are still going to remain positive. So it means that in this domain, starting from R onwards, we are going to meet one of these criteria because we say that f here is less than 0, while g prime, as you can see, here's our g prime, it's greater than 0. And therefore, since we know that the x value of r is 3 over 2, we can say that this inequality will be true for values of x that are greater or equal to 3 over 2. So that is how you can answer this question. I hope that makes sense because I understand that this part might be a little bit tricky, but just let me know in the comment section if there is anything that you do not fully understand, and I can try to make another video specifically dedicated to this question. Hope to see you on the next one. Otherwise, that's it for this video. I hope that you have enjoyed it and learned something from it.